Now, the dot point we've been asked to explain is, oh my god, use available evidence to gather and present data from secondary sources and analyze progress in the recent developments and use of a named biopolymer. This analysis should name the specific enzyme used or organism used to synthesize the material and an evaluation of the use or potential use of the polymer produced related to its properties. Okay. Now, what we need to do is that we need to use available evidence, which means resources from the internet, textbooks or whatever, to gather and present data from secondary sources and analyze progress in the recent developments and use of a named biopolymer. What a biopolymer is, it's a polymer basically, which is produced by a living bacteria or an enzyme. The analysis should name the specific enzymes used, so we have to actually name the enzyme or the bacteria or organism used to actually make the polymer. After that, we need to discuss its potential use and the properties of the product. Now, the biopolymer Imad and I have chosen is called BIOPOLT. BIOPOLT is made out of two things. It's made out of polyhydroxybutyrate, known as PHB, and polyhydroxyvalerate, which is PHV. The enzyme that will make this reaction occur and form a product is called alkylogenes eutrophus. Now, how it's made. A large amount of alkylogenes eutrophus is grown in an environment that it favors. This will allow the organism to be healthy and perform at an optimum level. Once this is done, a significant amount of bacteria will grow. The environment is altered so that the bacteria can produce a lot of glucose, which is the actual PHB, and valeric acid will also be produced at a large scale. Something that they don't want to be produced a lot is the nitrogen, which is considered a waste. The environment also induces the proportion of glucose produced by the bacteria, hence making it a lot more beneficial. The third step is after the bacteria has produced an acceptable amount of glucose and valeric acid, a large amount of chlorinated hydrocarbon is added to the bacteria. An example of a chlorinated hydrocarbon is just chloroform. And chloroform is also known as trichloromethane. Wink. What this does is that it'll break the cell wall of the bacteria, hence dissolving all the glucose and valeric acid inside the heated hydrocarbon, which is the chloroform. After this is done, the mixture is then filtered to remove wastes. The mixture is then extracted from the chlorinated hydrocarbon and it will be in the form of a powder, which is then melted to create a type of plastic known as PHB or the BIOPOLT. Now, the properties of BIOPOLT, these consist of the fact that it's biodegradable, it's biocompatible, it's non-toxic, insoluble in water, permeable to oxygen, resistant to UV light, acids and bases, high melting point and high tensile strength. Now, the advantages. As I just said, it's biodegradable, unlike high-density polyethylene or low-density polyethylene. This means that it doesn't take thousands of years to disintegrate, rather it takes a couple of weeks depending on the bacteria concentration around it. It is compatible with organisms, which means that it isn't rejected by the human body or it doesn't harm the human body, which is the which basically means it's biocompatible. It is a renewable source of energy and it won't run out as long as we have the enzyme alkylogenes eutrophus. The disadvantages is that it's really expensive to manufacture, and at the end of the day, no one cares about the environment or what's better or any of that crap. All they care about is that whether it's cheap or whether it's expensive, and most people will go for the least expensive alternative, which is the plastic that we use today. Another disadvantage is that say that it's on our shelves at the market and whatever, and like a really dirty kid decides to touch all the bottles in the supermarket. After a couple of weeks, if the bottles are still there, they will disintegrate because of the bacteria. And yeah. Something that I just want to go over before this ends is, this. Now, what it means by biodegradable is that the environment can take care of it. For example, the bacteria can make it disintegrate. Biocompatible, I just covered. It means that the organism can accept it. Non-toxic is simple. Insoluble to water, it means that it will not dissolve in water. Permeable to oxygen, this means that oxygen can go through the actual biopolymer. Resistant to UV light means that it is not affected by light, acids or bases. So any type of chemical you throw on it, it won't have an effect on it. The high melting point means that it can be used in piping, for example, because it's also insoluble to water underground, and high tensile strength means that it's like not weak and it'll break in a matter of seconds. It's actually durable. Yeah, thank you for bearing through my presentation.